Okay, so let's look at some basic behaviors of a logarithmic function, again using the things we talked about for all functions. So first of all, what's the domain? Well, when we look at the picture, it's essentially defined from 0 to infinity. It never crosses the y-axis, so x can't be 0, and all the graph is basically over on the positive side of the x-axis. So it's only defined for positive values of x. So logarithms of negative numbers are undefined. What about the range? Well, it goes to negative infinity pretty quickly, and then in this direction it approaches positive infinity relatively slow. So it's from negative infinity to infinity. Now, hopefully this is not a surprise, because when we were talking about a to the x, right, these were basically reversed. This is defined, the domain was everything, and the domain was actually, the range was actually limited to 0 to infinity. So because these are inverses, there should be no surprise that they're basically flip-flopping roles. So the domain for the logarithm, you always have to remain positive, and the range for the logarithm is any real number. In terms of intercepts, there is no y-intercept, right? It never crosses the y-axis, but the x-intercept, there is one, right? It's occurring, oops, that's bad. It's occurring at the point 1, 0. And again, no surprise, because we knew the reversal of that, 0, 1, was on the graph of the exponential growth curve, so I expect its reverse, right, 1, 0, to be on its inverse. So very much in the behavior of that inverse function. Some other things we can say is that in this case it is always increasing, right, throughout the domain. So throughout its domain, right, from 0 to infinity, the function is basically, as I trace it, it's always on its way up. So it starts really fast and then continues to go up at a slow rate. So it's a function that's always increasing, and therefore, since it's always increasing, like the exponential function, it has no extrema. It doesn't have a local min, it doesn't have a local max, it doesn't have an absolute min, it doesn't have an absolute max. All right, so there's no extrema for this graph. Another thing that we can kind of gather from that, from this, is it's not odd or even. It fails both our tests for that, right? To be even, it has to be symmetrical about the y-axis, and it's not. To be odd, it has to be symmetrical about the origin, which it's not. So we have another function that's not odd or even, just like our exponential function. End behavior, when we look at its end behavior, this is also a little switched up. End behavior, as x goes to infinity, our function also goes to infinity, but I would say slowly. All right, it's slowly going up. It's one of the big reasons why we do use a logarithm, because a logarithm of a big number is relatively small. So we'll talk more about that as we get into applications. As x approaches 0, right, so as we get closer and closer to 0, our f of x function is actually going to negative infinity, and it's going there quite fast, right? It's exploding downwards. And as a matter of fact, what I should also do is put a little plus by that, because there's two ways to approach 0, from the plus side and from the negative side, and we're approaching from the positive side. So as x gets closer and closer and closer and closer to 0, the function value is going to negative infinity very, very fast. It doesn't have a horizontal asymptote, but it does appear to have a vertical asymptote of the y-axis, or we know to be x equals 0. Again, this behavior is happening, right, definitely in this direction right there. So there does seem to be a vertical asymptote occurring. Okay, so when we start transforming this like we do, not only going to be transforming, moving this point up or down, we're definitely going to be moving that vertical asymptote left or right, which will also now impact the domain if I do that kind of shift. And then last but not least, it is 1 to 1, right, which is no surprise, and there's its inverse function. So the a to the x serves as the inverse function for log base a to the x. So there's your basic shape. There's some of its basic patterns and things we can say: its domain, its range, its intercepts, its extrema, end behavior, asymptotic behavior, all that good stuff. And so now that we have a basic shape, what do we usually do? We start to transform it. All right, so we move it left, we move it right, we stretch it, we shrink it, we flip it, we start doing all those crazy things. So we'll do that in a video coming soon.